Hello everyone, Radhe and welcome back to my channel. Today we are back again with discussing today's LeetCode problem of the day. So here we go. And before beginning, just to take you guys with me, let me tell you that this problem involves dynamic programming and recursive way of thinking. So if you are not comfortable with the DP and some hard problems, so I guess it's better for you to first learn those fundamental concepts first and then come back to this problem. Otherwise we're good. So let's begin. So the problem says we have been given two strings s1 and s2. We have been given two strings s1 and s2, and we need to return the lowest as ASCII sum of deleted characters to make both of the strings equal. So I need to make both of the strings equal. So if my first string is SEA and if my second string is EAT, so I need to make them equal by deleting some characters, right? I could delete any characters from the first string and I could delete any characters from the second string. So in this case it is optimal to delete S from the first string and T from the second string, because I want in the at the end I want both of the strings to be equal, right? So don't you agree that in order or let's think about it in this way, we first of all need to find the lowest ASCII sum of deleted characters, right? So I need to delete the characters in such a way that their ASCII sum is as minimum as possible, right? So for that particular thing I've written down a note here. What this note actually says is deleting less characters is always optimal than deleting more characters. So suppose I delete 3 characters, right? So if I delete 3 characters, let's say my on average ASCII value for 3 deleted characters would be 300. Let's say for now, on average. And if I delete 2 characters, let's say on average my ASCII value would be 200. So that is exactly what I'm saying, that deleting 2 characters is always optimal than deleting 3 characters. Or in other words, if my more characters will remain in the last string, right? So I need to make s equals to t, or both of the strings equal. I need to make both of the strings equal. So isn't it always optimal for the last string to be as maximum as possible or as long as possible? So if I had a string like A, B, C, D, E, and if I had a string like A, B, E, then I would say it is always optimal to pick this A, B, E from here and A, B, E from here, right? I could match both of them together, and it is always optimal for the longest possible string to remain at the end. Because if the longest possible string remain at the end, then what exactly happens is I will delete less number of characters or least number of characters, because at the end the maximum possible length string is remaining, right? So if maximum possible length string is remaining, then I'm deleting minimum number of characters. Those statements are exactly the same. So to show you guys that thing, I've written some points here. According to that, it will be much easier for you to think about problems like these. So first point is rephrase the problem to think about the characters that will remain. So in this problem, the problem has stated that we need to delete the characters in such a way that their ASCII value is minimum possible. But what I'm saying here, rephrase the problem to think about the characters that will remain. So let's not think about the characters that we need to delete. Let's think about the characters that will remain till the end. So what are the characters that will remain till the end? What do you think will be the characters that will remain till the end? That will be the characters that will be common in both of the strings will remain in the end, right? So if I had an I'm sorry, just a minute. So if I had an A here in the first string, and if I had after some gibberish I had an A here, in the second string, then if both of them are common in these strings, right, then that has to remain in the end, or that is one possibility that it could remain in the end, right? So that is what, that is a sequence or subsequence, right? So I need to choose a subsequence from both of the strings. So I need to choose a subsequence. So if my example would be LEXXET, this is my first string, and my second string is, let's say, LET. So choose a subsequence from both of the strings such that they are common in both. So choose the subsequence as, I choose L, E and T, and I choose LET here. So now both of the subsequence are equal, and this is the maximum possible subsequence, or this is the maximum possible length subsequence that could be generated. And so this will remain till the end, and whatever is left in the string, in both of the strings, suppose we had y something like that in this second string, then we can just delete those characters, and I could prove that this is the least number of characters with least ASCII value that will remain in the end, or that I will have to delete. I'm sorry, I will have to delete, because this is the 3 length subsequence is the maximum that could remain in the end, right? So I'm just trying to take your perspective in opposite direction to what is given in the problem. Now if it is clear, let's move on to the second point, that can there be a greedy solution? Can there be a greedy solution? So to think about the greedy solution, I would like you to think about this particular test case. In this test case, what is the maximum possible subsequence or maximum possible length subsequence that could be there? So if I choose this x, I had an x over here. If I choose this t, I have a t over here. If I choose this x, I have an x over here. So a 3 length subsequence is the maximum possible over here, right? But suppose if you would have chosen this g instead of choosing this t, if you had chosen this g, so you would have to match that, you would have taken this g, and now you cannot take anything after that. This is the subsequence that you could make finally, right? So this is a 2 length subsequence, but I'm saying I want maximum number of characters to remain in the end, so that I will have to delete minimum number of characters. So in order to do that, I cannot do this greedily. I have no optimal way to do this greedily. I will just have to generate all of the possible subsequences and check for those. So I match x with x, I match t with t, and I match x with x, and this 3 length subsequence is the maximum possible, and whatever are the characters that are remaining, so these characters here are remaining, right? This a, b, d, y, g, I could just take the ASCII value for those, and then I could return this, and this is the minimum possible answer for this one, this particular test case, right? So how now our problem is just reduced to finding the longest possible subsequence among 2 strings. And does something ring in your head when you hear this longest common subsequence? Longest common subsequence? Actually, this is a very standard problem. I'm sorry, subsequence. This is known as LCS. This is a very standard dynamic programming problem that if you were learning DP, then you would have solved this. So now our problem is reduced to just finding longest common subsequence, and not just finding longest common subsequence. We need to find the longest common subsequence which has the maximum possible ASCII value. Alright, so first of all, this problem boils down to just finding longest common subsequence, and we do not need to find any longest common subsequence. We need to find the longest common subsequence which maximizes my ASCII value. So because essentially I'm thinking about the elements which will remain in the string, right? So I want the first of all, I want the characters to be, the length of the characters to be as maximum as possible, and then I want those characters to have the maximum ASCII value, so that I will have to delete the minimum ASCII value elements, right? So does that make sense? I hope that makes sense, because these two statements are actually negation of negation of each other, right? So now I find longest common subsequence with maximum possible ASCII value, and that is just, you can do this with dynamic programming, easy dynamic programming solution like you did with LCS. So suppose you have two strings like A, B, C, D, and you have G, B, E, something like that. This is my first string, this is my second string. Alright, just a minute. Alright, so I'll just remind you guys about the LCS problem. So initially we had two parameters. One is I, initially it is 0, initially j is also 0, so we have two parameters. Now we match these characters. If my s of I is equal to t of j, which it is not in this case, then I have two possibilities. I could either, in the first case, I could either increment I by 1 and keep j as it is, or in the second case I could keep I as it is and increment j by 1. So I have two possibilities for this particular case, right? So now my two possibilities could look as A, B, C, D and G, B, E. And now I have incremented, this is the case for the first one. So I have incremented my I, so my I is here and my j is here. J is here, right? And according to this particular case, G, B, E, my j is now here and my I is over here. So I have these two cases now. And similarly now I could check again, is my I is equals to, s of I is equals to t of j? It is not. So I have again two possibilities. In one I could increment I by 1, keep j as it is. In the second one I could increment j by 1 and keep I as it is. Similarly for this one also I have two possibilities. But now let's see, I have two possibilities. First of all, I could increment I by 1. So if I increment I by 1, my result becomes something like G, B, E. So now my I is here and j is here, right? So now my s of I is actually equals to s of j. So as soon as my s of I equals to s of j, that means I have found a valid, common subsequence, common one length subsequence. Then in that particular case I could just return 2 into ASCII value of s of j or s of I or t of j, whatever you want. Why I'm doing 2 into ASCII value? Because I will take both of them into account, right? So both of the ASCII value will remain in the end. So it is not only that this b is remaining, both of these b are remaining, right? So I'll take 2 into ASCII value of that particular thing, and I will simultaneously take maximum of both the cases when my s of I is not equals to t of j. So in this case, if my s of I is not equals to t of j, then I would take maximum of these two cases. So maximum of these two cases, whatever the result gives me, whatever the maximum is among these two cases, I set this to dp of ij. As I and j are the only changing parameters over here, so so the problem I think is done, and we could just return the final answer using dp of n-1 and m-1, and that's probably it. That's it to the problem. And actually one more thing, that dp of n-1 m-1 gives the maximum possible length subsequence which have maximum ASCII value, but we need to find the least possible ASCII value of the character that I need to delete. So if I subtract this from total ASCII value, then we'll get our answer. So we just need to subtract that from total ASCII value, right? And then we have found our answer, and that's it. I'll show you guys the code. This is the code. So I'm first initializing my dp with -1. I've created a 2D dp of size 1000 and 1000, since length could be up to 1000. And then I've pre-calculated my total ASCII value of both the strings, and then I've subtracted the maximum possible length subsequence of maximum ASCII value from the total ASCII value. Now how exactly we have calculated this? We can see that if this is my base case, if my I is equals to the last element, or if my j is equals to the last element, then I cannot match any more elements, so I return 0 from there. If my state is already pre-calculated, then I could just return that state. Now we have two cases. If my current element is equals to that, if my s of I is equals to t of j, or if my both of the characters of strings are equal, then I could add 2 into ASCII value for that particular character, and I could make a call to I plus 1 and j plus 1. I could just increment both of the pointers by 1, because it doesn't make sense to even divide that into two cases, because those characters have just matched. So you can now just go and compare the rest of the characters, so I plus 1 and j plus 1. And if my both characters do not match, then I have two possibilities. I could either increment I by 1 and leave j as it is, or either I could increment j by 1 and leave I as it is, and I could take the maximum of both those cases. And that's it for the problem. So I hope I was able to explain to you this problem well. This wasn't actually very difficult. We just needed to think in the opposite direction of what was given in the problem, and I hope you got it. And if you haven't got it, you can please ask me in the comment section. You're free to do that. And I'll see you guys in the next one. Please stay tuned. I have a lot of content planned for this channel, and yeah, guys, I'll see you guys in the next one. Thank you, and Radhe Radhe.